Our next speaker is Dr. Gerald Hendry, and Dr. Hendry is an Athletic Association endowed professor of environmental turf science at the University of Georgia. He earned his bachelor's and master's in plant science and plant biology from Rutgers University and a doctoral degree in crop science from North Carolina State University. He's the director of the Athens Turfgrass Research and Education Center, the undergrad coordinator for the Department of Crop and Soil Sciences, and the director of the UGA Turfgrass Management Program. His research focuses on sports field management, turfgrass management, meat biology and ecology, and ecosystem services. Dr. Hendry, the floor is yours, okay?
Thank you. Okay, so I am going to go in a completely different direction here. We're going to start talking a little bit about some engineering and quite a bit about sensor technology and performance testing. I don't have to read this first slide since Shumat did a great job of introducing me, but I do have a split appointment between research and teaching. With a little bit more research with 60% versus my 40% teaching appointment. So again, I don't have to go through this either, but I am sort of a hybrid. So I work a lot in sports turf management with a focus on precision. But I also have a background in weed biology and ecology and do quite a bit of work in ecosystem services. So can I go right into the talk here? Again, a lot of what I do, I'd say 50% of my program has to do with sports field playability. And with that, where I was looking at trying to reduce injury by using a lot of cutting edge technology. And I'll kind of go through some of that as I go through this presentation. So when it comes to athlete injuries, it doesn't matter if you put somebody in a suit of armor, they're always going to occur. But usually, with respect to some of the groups that we deal with, most of this focus is primarily placed on safety equipment. And as a turfgrass person, I know that field playability is heavily linked to player safety. And it's not just the equipment that they are wearing, but it's obviously the field that they're playing on and how that field is performing. So we've started to do a lot of work in my field on what we call performance testing. So we're gathering information about the fields and even the facilities that may contain dozens of fields and how they perform. It can be anything from low technology to just a pad of paper and a pencil where you're taking notes during your daily rounds, or you can get into some of the high-tech stuff that I'll go through as I go through the presentation. So we're looking at a lot of player surface interactions. Specifically trying to look at everything from compaction to surface hardness to the uniformity of the canopy, and then how well some of these fields hold up with the wear and the traffic that we expose them to. I get to work with a lot of fields that are at this level, as we call them, the professional level. As you can see, pretty well manicured soccer complex. Lots of money, labor, and inputs are put into these fields. So most of the time, there's not much for me to recommend or to even comment on, aside from the fact that they're really, aesthetically pleasing. So we spend a lot of our time at the community sports level, simply because we know that that's where there's less inputs, less labor available. The fields are overused, and they tend not to hold up to a lot of the wear and traffic. And we're also dealing with younger athletes, and we're trying to prevent some of these injuries at younger ages, simply because we don't want those injuries to compound to the point where by the time they get to the collegiate, and even if they get to the professional level, they may be disqualified because the number of injuries that have occurred exceed the limit that is required or that is allowed in certain sports. So unfortunately, this is a local picture from the county that I'm in Oconee. This is taken several years ago. We had worked with the county with some of these fields. You can see that there's some issues with this field as far as surface coverage with the canopy, water infiltration. There's some compaction issues, but obviously not something that someone wants to play on. I'm sure these students are having a lot of fun, but it's definitely not a field that's going to hold up over a lengthy period of time throughout the entire season. So unfortunately, not a lot of money was put into managing the fields, but there was some money that was found to convert both of our fields for both of our high schools in our county to synthetic surfaces. Won't get into the real versus synthetic debate, but it is unfortunate that we are not able to find money to manage the natural grass fields, but we can quickly find money, exorbitant amounts of money to convert to synthetic systems. So obviously, this poses some environmental concerns once these fields are out of commission, and a lot of times they're sold with a guarantee of 10 years, but when they are moved outdoors, that guarantee is pretty much cut in half. If you can get 5 years of use out of them before they start to break down, you are lucky, just due to photo degradation and wear. Most of them are not managed very well, simply because they are sold with the expectations that the management is no longer necessary, and that's definitely not the case. So they are considered in hazardous waste once they are disposed, and obviously we don't need more sources of plastic in the environment. So a lot of the environmental concerns outweigh the use of synthetic turf at this point. So what my program strives to do is to create, a well-performing system that has a uniform above-ground canopy and a relatively good functioning root system that not only helps the field perform well, but obviously also creates a good environment, good turfgrass environment for us to use, not only as a playing surface, but also for water infiltration and filtration and things like that. Unfortunately, though, even though we can look across a field and notice that the canopy is relatively uniform, none of us really have X-ray eyes to understand what's going on below the surface. We tend to have a lot of variability in rooting, simply because of some of the differences, the variability in certain things that are going on below the surface, whether it's soil moisture, compaction, or various other things that can influence our rooting. And it's these areas that are prone to breaking down during some of the field play, creating some issues for a lot of our athletes. And that's what we're really focused on, is understanding the variability of some of these fields and trying to manage that variability and therefore increase the safety. So we're looking at lots of different measurable variables and how all of those variables then impact both root length and mass. So everything from moisture all the way down to even thatch layers, and again, how those influence root length and root mass. So we've been doing lots of research over the past couple of years, probably the last 10 years, going out and taking samples from various fields throughout the state of Georgia and even some neighboring states, and trying to make correlations between some of the things that we're seeing with respect to environmental parameters, and then how those environmental parameters affect root mass and depth, hoping that we can come up with some management tactics that could improve the uniformity of some of these field properties and therefore increase the uniformity of the rooting system. So not to get into too much with this graph here, it's just kind of showing that there's relationships between all of these different field variables and roots, whether they're surface roots or roots deep in the profile. And again, this is kind of showing different correlations between some of these variables, whether they're positive or negative, and the strength of these correlations. And we use this to understand, or better understand, how all of these variables influence rooting. And then again, kind of helps us determine what we need to focus on the most with specific fields when it comes to trying to increase the root system. So most of this variability is measured with some pretty high-tech devices. This is probably something you couldn't do with a pad of paper and a pencil. We are, as you go from left to right, we are basically out in the field, and we are taking samples with different types of units, and we are then taking those data points and we are converting them into continuous maps on the far right. This is an example of turfgrass health, and you can see the areas that are in red match up with the microfields that were created on the field in the center. where most of the play is from left to right across both of the center areas of both of these microfields. So again, we're taking a lot of data and then turning them into useful map layers that we can then query to figure out exactly what's going on with some of these fields. So we use a lot of high-tech technology. Unfortunately, some of it's getting a little bit more affordable as the years go by, but we actually have access to some extremely expensive technology, which just allows us to take data a lot quicker. So this is a picture of the Precision Sense from Toro, and I won't get too much into the sensors, but just to kind of give you an idea, this is a device that we can tow behind a utility vehicle that will give us all kinds of different types of data that we can then kind of combine and query to see what's going on with each specific field. So we are using this with our research and also using this with our survey analyses of certain fields throughout the state. So we use a lot of handheld sensors, anything that from an NDVI meter in the upper left there that measures plant health, all the way down to the lower right corner there is a compaction meter. The lower left corner there is a traction meter and a soil meter and a clay hammer, which is in the center there in red, which is also measuring surface hardness, so the upper level of compaction within the soil. We also have access to lots of different mobile sensors. Again, the Precision Sense, the Veris technology in the upper right corner, a mobile EMI unit, electromagnetic induction, some drones, and a few other types of mobile sensors that we have at our disposal or we can get access to through various companies. So a lot of times we are taking certain sensors and we are using them simultaneously. So this is some work that we are doing with the Precision Sense, the mobile device, and then also coupling that with the drone and being able to sort of tie in some of the data we're collecting with the drone with certain sensors attached to it. And then also ground truthing that with devices closer to the surface. Usually the closer you are to the surface, the more accurate you are with some of the different information that you're gathering with the different sensors that you're using. So again, one of the things that we really wanted to figure out pretty quick was, are we getting the same type of information with the handheld devices as we are with the extremely expensive mobile devices? And the long story short there is that we are, and with the exception of one device, which is the soil penetrometer. So if you're ever keeping compaction readings with a handheld device, just understand that you want to try to be as uniform as possible with the use. You want to try to use the same person with the same amount of force inserting the meter into the ground, because there's a lot of variability there when you go from one person to the next. And just the process of using a handheld soil penetrometer is relatively difficult. And sometimes the data that you acquire with it is not necessarily the most accurate. All right, so just to kind of get you into what our thought process was early on when we started doing some of this work is that we wanted to look at how were fields evaluated, early on with respect to performance testing. So looking at historical testing procedures, this is a typical testing procedure for an American football field. Looking at surface hardness, and as you can tell, there's only 10 areas that are sampled. Some of those areas you would suspect the end zones and the sidelines not to be very compact, and then certain other areas as well. Whereas position 1, 4, and 6 down the center of the hash marks, you would suspect that those areas are relatively compact. So just the locations of the sampling in our minds made us think that the data, once you obtained it and came up with an average, was always going to give you a relatively safe number. I won't get into what the numbers are specifically, but we just had some difficulty understanding how that was really giving you an idea of how the entire surface played. So one of our issues is that the locations are limited to the highest number usually you'll take is around 12, so they're less than a dozen. And, we really wanted to understand what's going on in some of these other areas, because you can have a safe part of the field and then, within 5 to 10 yards away from the sample that you're taking that's quote unquote safe, you may have an area that's not safe. So we went into sort of our engineering mode here and tried to determine what the minimum number of samples were needed to accurately depict field performance with respect to every single thing that we were measuring. And so we did know that sample number was going to vary, depending upon whether you were measuring soil moisture, compaction, or something else. But I only have 3 examples here looking at the accuracy of sample size. The highest number we sampled was 450 samples across a standard American football field. And then we went all the way down to a low of 36 samples. So you can see there's a pretty big range here of sample size. And what we wanted to look at was, how did the pattern with respect to what we were measuring, in this case, it's soil moisture, how did that pattern change as we went from 450 samples all the way down to 36? So as if you look at the means across the board there, regardless of whether or not you're taking 450 samples or 36 samples, your mean is pretty close to 22, which is kind of what we thought based off of the historical testing procedures, that if you don't take enough samples and you base everything off of mean, you really don't understand exactly how that field is performing spatially. So if you look at the 450 versus the 115, you can kind of see that pattern does not change much. So we knew that the sample size would be somewhere around 100 or so. So we were able to kind of hone in on that, and that kind of got us in the right direction with respect to where we were going to go with how we were going to start to sample fields. So one of the big projects that we worked on in the last 5 years has been collaborating with the UGA Biomechanics Lab and our rec sports teams. And we started to monitor men's and women's rugby, ultimate frisbee, soccer, and lacrosse. And a little hard to get students to participate unless you bribe them with things. So we had various benefits for getting students to enter into our research, but we had a pretty decent number of students that we were monitoring over the 2-year period across several sports, both male and female. And we always want to do baseline screens of all these participants. We don't want somebody that's prone to injury to get involved in our research. So we run them through the same functional movement screens that you would see participants in the NFL do before they get drafted, to determine what the potential for injury risk was. And if there was a candidate that just had, was not healthy enough, we obviously didn't allow them to enter into our research. So again, this is an example of the functional movement screen, and the perfect score is 21. And I believe we were aiming for a score of 17 or better in order to participate in our research. So we were surveying through the biomechanics lab. We had a PhD student that was attending all the different practices and games, several actually, and sort of surveying students as they were injured. It is required by students through rec sports to actually self-report, along with anyone that is at the facility or the field who's monitoring to also report. So we were getting everything from injury location to the type of injury, and various other types of information, obviously the person and so on. And we were simultaneously measuring lots of field measurements. So weekly soil moisture and turf grass health, biweekly surface hardness and shear strength. And we were converting these into what we call hotspot analysis. So if we looked at soil moisture, we were taking all of the moisture that was the areas that were extremely wet versus the areas that were extremely dry. And then the median in the middle, we were not really focusing on. So it was really, the cold and the hot spots with respect to each one of these characteristics. We were creating these maps that were gridded out. And then we were locating, obviously, geo-referenced injuries. This is an example of the 2 fields we were monitoring and some of the injuries that we had that are indicated by stars. The boxes are areas that we had an injury that was reported where a person sort of slid and couldn't exactly tell exactly the grid spot that they had been injured in, but the injury made sense to us, so we entered it into the research. So we could overlay these injuries, and we could take a look at where they were located, and then obviously we knew the type of conditions that were present at the time, roughly. and we could start to make correlations between injury type and the conditions that were present. So I know 23 injuries doesn't seem like much, but over a season, it's quite a bit. And again, these are not all the injuries. They're injuries that met the criteria that we had set up. And we were able to evaluate those with respect to all the different parameters that we were measuring. Pretty much what we thought. There's about 75% of the injuries were lower limb. That's kind of what we were guessing with the type of data and the type of sports that we were looking at. And we were able to make correlations between a lot of these injuries and certain parameters. So soil moisture was highly correlated to most of the injuries that we saw. Same thing with turf grass quality. And then pretty close to 60% for surface hardness and shear strength. One of the other things that we did notice when we started to look at locations is we saw an edge effect. And we were seeing lots of injuries that were occurring where you went from one extreme to the next. And again, we didn't know if it was where athletes were actually coming into they were hitting these areas where these two extremes met, or if it was the actual movement from one side of the extreme to the other that was causing the injury. So again, probably ended up getting more questions from our research than we did answers. So we also like to look at the psyche of athletes. So we did some work with another person in our group looking at athlete perceptions. So we would take the athletes out to the same fields that they were performing on, and we would do walking interviews. So basically an interview every month for an entire season. And we would ask all these different types of questions, trying to get an idea of where the athletes thought the field was safe, where it wasn't, where the field played well, where it didn't, how different things affected their psyche and various other topics. And as you can see over time, the fields do not hold up as well as we'd like them to because they are overplayed. There are a half dozen different sports that are played on these fields. And again, the amount of inputs and management that these fields receive is just not, to an adequate level. So again, we were correlating things that these athletes were saying with a lot of the data that we were taking on the same fields that they were walking. And then we would come up with sort of these phylogenetic trees of concepts, and we're able to really start to boil these statements down into certain perceptions that the athletes had. And we were able to look at, simple things as far as changes in behavior. So, there may be an athlete that said, or we were able to determine that certain things that were going on in the field were actually making them adjust the way that they were playing. And then obviously that would affect their performance. And then potentially, some of these things were affecting strategy in practice versus game. So it was really interesting to see how the field played into the psyche of some of these athletes. So this really led us to some of the work that my grad students are doing right now. So we do know that we made lots of correlations between field conditions and injuries, but we didn't really have what we call quote unquote real-time data. So although we would have data that maybe we collected on a Monday, but injuries were occurring on a Thursday, the data that we were getting on that Monday isn't necessarily indicative of the exact condition of the field on Thursday when that player was injured. It's pretty similar, but it's not real time. So again, I have a little bit of an engineering background, so we started to create these miniature fields in the greenhouse. We call these ground reaction platforms. We grow out turf grass on a soil or sand profile. There's a cutout on the bottom that allows us to insert a force plate, which is sort of a fancy scale, and we can get all kinds of different forces in response to athletes from below, and I'll kind of explain how this works here in a second. So we can grow out these fields, including the root system and the entire profile, to get an idea of not just how the surface interacts with the athlete, but what the entire profile does in response to an athlete doing a maneuver on the surface. So we grew out lots of these fields in the greenhouse. Pretty grueling task to grow some of these in the greenhouse and keep them at the level we wanted to. But as you can see, we had some pretty good surfaces that we ended up with. Potential use for a lot of this stuff is everything from comparing natural turf grass to artificial turf, different types of profiles, different types of systems, and even evaluating different cultivars and species. But for for sake of what we were doing initially, we were really just trying to get some initial data to see how fields were interacting with players in a real-time situation. So again, we do a lot of collaboration with the biomechanics lab. So we were having athletes do different maneuvers on these devices. We use both the force plate underneath the device to get vertical forces exerted on their body in response to their body doing some sort of an interaction with the surface. And then we also have markers or sensors on their body in certain positions, and we have a motion capture system surrounding them that we can get an idea of how their body interacts with the surface, and then also simultaneously getting the forces exerted back on their body when they do certain motions. So this is just kind of showing you a couple of pictures of how we do some of this and some of the setups. So we focused on certain joints and certain portions of the lower limbs. Again, predominantly looking at lower limb because we know that's where most of our injuries are. And because this was sort of new technology for us, my grad students got to test a lot of this stuff in our maintenance building. So we were looking at just jumping on the force plate by itself. And then we were looking at, just covering it over with some sand, and then also looking at covering it over with some synthetic turf, and just kind of looking at how the force plate responded to what we were doing. So again, preliminary data pretty much showed us that we were getting the type of response that we thought we would get. And we're actually running tons of work right now that I don't have anything to update yet, but we know that the device is functioning properly. It's based off of your personal weight. When you jump on the device, you're exerting a certain amount of force based off of your weight, and then that force is being exerted back on you. Usually it all depends on what is between you and the force plate with respect to how much force is being exerted back on your body. So again, kind of going through the proof of concept this summer, and we were looking at native soil versus sand-based systems and different depths of profiles. And we had one of our undergraduate student workers as our guinea pig, and we had the motion capture system set up, and we had Seth here go through several different types of maneuvers, and we were looking again at how much or what the interaction was between his body and this entire system. So from there, we're kind of moving out into the field. Again, this is an example of what you would see if you watch the combine, or certain maneuvers that these athletes are making. So one of the things that we're really interested in is sort of the takeoff, and so the acceleration and the deceleration is where you get most injuries, and then certain cutting motions. And we know that we can't do that in the lab or in the greenhouse. So we kind of move outside. And again, this is where some of the technology has been expanding for us. So a lot of the stuff you could only do in an enclosed lab, but now we have a lot of different tracking devices and sensors that we can utilize in conjunction with our research to better understand how these athletes interact with the surfaces in a field setting. This past summer, and I should have updated this with some pictures of everything that's grown in, but one of my grad students has built a significantly large area that has running lanes that are 5 feet long by 90 feet wide, and each one of these lanes represents different types of grasses. We are also looking at combinations of weeds and grasses. We're also looking at synthetic turf, overseeded turf, all kinds of different things to look at how, when these athletes run down these lanes, how their body interacts with the surface. So again, as some examples here, we're definitely looking at natural grass and synthetic turf. And then one of the other questions we're trying to answer is, does overseeding dormant Bermuda grass, is it more beneficial or detrimental when it comes to player safety and performance? We actually stopped overseeding our stadium here because our head coach feels like the ryegrass actually is too slippery, and it is more of a detriment to the athletic ability. So we're now painting, which I'm not sure that's a better choice, but hopefully we can come up with some answers on that subject. So we're also really looking into weed pressure, because we are aware in the Northeast and the Northwest, there's a lot of moratoriums on spraying pesticides on athletic fields. And we're trying to come up with some data that shows that the more weeds that you have in your system, the more unsafe these systems are, and therefore you have to spray and use pesticides in order to control weeds. So that's part of our push as well. So we're kind of focusing on annual bluegrass, white clover, and large crabgrass. And my one of my grad students is actually running some pilot tests right now, where he has certain athletes that are rigged up with different sensors, and we're just trying to get an idea of how, what kind of footing they have in certain combinations of these weeds, certain percentages versus the weeds to the grass. And again, just trying to get some preliminary data and then eventually expand the study. So one of the other things that we're doing is we've taken the traffic simulator that my colleague, Dr. Brian Schwartz in Tifton, created years ago. And through help from the engineering group here, we have refabricated this device and made it better. And we are using this to simulate wear in traffic. And with one pass of the device that we have, we can simulate an entire football game in a matter of minutes. So that allows us to add an extra layer to some of our work, and we can start to wear down some of these areas. And then again, take a look at the interaction between the athletes and safety with respect to these different types of surfaces and mixtures when they are fresh at the beginning of the season, and then what they end up looking like, midway and towards the end of the season. So again, we can do this sped up very quickly, so we don't have to wait until the end of the year to gather some of this data. We can get it pretty quick. So again, lots of different sensors in the field that we hook up to athletes, pretty similar scenarios to what we do in the greenhouse and in the lab. We just purchased quite a few more sensors, and we can get an idea of the slip differential when an athlete starts and stops in some of these situations, not only based off of the surface, but also based off of what's going on below the surface with respect to the roots, and also things like soil moisture, compaction, surface hardness, and various other characteristics that are going on below. This is some other work that one of my master's students is working on. So we are constantly noticing that fields are being painted with more and more paint, and we were curious as to what happens to the paint as the years go by. And this is actually taken from an athletic field down in Tifton, Georgia, and a little hard to see in the picture, but we're starting to see layers of paint that is moving through the profile. And one of the things that we know, or that we're theorizing, is that it is decreasing not only rooting potential and rooting depth, but it's also decreasing or affecting water infiltration. And a lot of times people will restart a field by simply shaving off the upper profile and then coming in and resodding. And when you have these layers of paint that you lay the sod over top of, we're starting to think that maybe the roots are not pegging down as well. And therefore, there's a safety issue with that as well. So not only are we looking at that, but we are looking at also painting surfaces, both, warm season grasses and cool season grasses, and looking at not only the amount of paint that we're applying, but the technique that's used, whether it's roll on or spray on paint, and how that also affects player surface interactions in the field. So again, what our whole goal is to combine data on field conditions that are leading to an increase in injury occurrence, and with understanding of how conditions change over time. And by combining these two aspects, we're hoping to make adjustments prior to play that can also increase player safety. So again, our focus is trying to decrease that variability. Obviously hard to see, but easy to theorize. When you start to understand variability in soil moisture and compaction, you can almost understand that variability is going to lead to a variability in the rooting system. And you can sort of overlay some of these maps and theorize where you have inconsistencies. And it's the inconsistencies that we're trying to manage. Again, you're never going to make everything uniform, but you can obviously make an attempt to increase that uniformity. So again, we have different things at our disposal that we can use. This is some work that we conducted on golf courses looking at mapping soil pH variability with different devices and understanding that has an influence on, how you would fertilize and the response to fertility and things like that. And then obviously that has a long-term effect on your rooting in response to not only the soil pH, but the fertility applications that you're applying. We've also sort of fine-tuned the way that we do irrigation audits now. So getting away from catch cans, because that's really only giving you an understanding of where the water is landing. It's not really giving you an understanding of where the water goes when it hits the surface. So we combo doing catch cans with actually mapping soil moisture in the profile to give us sort of a two-layered approach to better understand water uniformity and spatial characteristics within the system, and then how to fine tune your irrigation system to go in and maybe make agronomic changes. Maybe you have areas that are too compacted, and that's why the water is not infiltrating accurately. And so again, it's giving us highlights as to where and what we can do with respect to management. And then lastly here, we do a lot of in situ research where we will actually put trials out on fields that are being played continuously. And as you can see, the rec sports fields on campus get beat up pretty quickly. Again, there's anything from rugby to lacrosse to soccer to various other ultimate frisbee and various other sports that are played on the same field. So there is no true pattern of anything here with respect to sports that are played on it. The entire surface gets pretty worn down pretty quickly. So if we put trials out here, we know that if we're getting some positive results with respect to what we're seeing here, that we're going to see that same result if we were to use this on another system. So one of the cool things that we've been looking at here recently is sort of a new plant growth regulator technology, sort of getting more away from the regulation, but sort of, I guess the easiest way to explain it is sort of regulating one portion of the plants while releasing products that can be utilized by the plant for a benefit. So again, this methyl alpha product here, GlucoPro, is not registered in turf yet, but it's something that we're messing around with. It unlocks and releases glucose that's bound to lectin proteins found in high concentrations in the plant roots. So it basically releases a flush, all this glucose that provides a flush of energy that can not only lead to a flush in root production, but it can also help with various other biological functions. So this is one thing that we've been examining that's been pretty cool. And again, I would say pictures are the greatest things to look at here. So one of the things that we battle quite a bit in sports turf is the heavy use of urea. And I try to explain to people that you do not want to only use urea as your source of nitrogen. You want to try and vary some of your sources, simply because when we compare other products to urea, we always seem to outcompete urea. I understand it's cheap and it's easy to access, but we never see a great response with root systems to urea because it creates too much of an above ground flush. And what happens is your root system sort of suffers in response to that. So you get too much of a canopy response and not enough of a root response. So again, you can see the 3 samples we pulled out of the ground that we got out of the GlucoPro treatments, and you can see the amount of not just depth, but mass that we see in response to some of these treatments. Again, 3 months after initial treatment, and these are plots that are being trafficked simultaneously. So this is not something thrown in the greenhouse under pristine conditions. These are tough conditions to try and grow plants under, and they are not only growing, but they're performing and outperforming some of the typical products that are used in turf grass. With that, I know I probably sped through that pretty quickly, but as a typical person who teaches and doesn't do extension, I have way too many slides. And again, hopefully this will give you some opportunity to ask some questions.
Thank you so much, Gerald. So let's wait for a few minutes. So if you have any questions, please use the Q&A box, and you can type your question and I can read it out. So Gerald, since we're waiting for a question, maybe I can ask you an etymology question.
You can ask me an entomology question?
Can I ask one question related to entomology, maybe not relevant, maybe not related to you, but have you seen any root feeding insect problems in athletic fields in general? That's how common that is.
We actually see the two biggest things that we see are armyworms is an issue. Obviously, that's not root feeding. It can cause a lot of canopy defoliation, but we do see grub issues quite a bit. And the thing that I think will get worse is that as more and more pressure is put on field managers to decrease pesticide use, I think you're going to see a lot more issues with both grub feeding, and I think you're going to see a lot more issues with fire ants. And those are the two most problematic for us in athletic fields.
So are you seeing these grub issues across the state, or is there any particular part of the state that you're seeing a lot of issues?
It's not necessarily with respect to location, but it obviously goes hand in hand with whether or not we're getting enough rainfall and whether or not these fields are irrigated or not. So that's usually the big thing. I mean, if we get into drought situations, we see a massive decrease in grub pressure. Same thing with fire ants. But then as soon as you get some rainfall, everything comes coming back like gangbusters. So it goes more hand in hand with the environment, not necessarily so much with location in the state, at least for what I see.
The ant issues can be severe because that's a safety problem too, right?
Yeah. Yeah. The other thing too with controlling weeds on the safety side is, especially with we get a lot of white clover in fields that are not fertilized well. And there's a lot of children and even adults that can have some issues from bee stings. So, you get a lot of pollinator visitation from white clover. So that can create some problems too. So usually, again, it's a low end community sports field issue that could be solved with some basic inputs. But I think that's going to become more problematic as a lot of that stuff gets, shifted out. People are even having concerns with synthetic fertilizers. So just things that we don't really even think that are problematic. A lot of people are concerned that they don't want their children to interact with a synthetic fertilizer. So we'll see what happens in the future.
Right. And you indicated about synthetic. So what percent of the, like all the athletic fields that you got in high school and above, you think they are converted into synthetic at this point?
I don't know if I can put a big number on that or an accurate number, but it's occurring more frequently. And you have to understand that all the companies that make synthetic turf are the same companies that produce carpet. So they have a really good marketing plan, and they're very focused on pushing attributes that aren't necessarily coming true when you actually install these systems. And they're also not giving a lot of education as to how to manage these systems. So most of the schools that are switching from real grass to synthetic don't have the equipment now to manage the synthetic. So they tend to get problematic within the first couple of years. And a lot of times we're seeing a lot more schools hiring outside sources to come in and try and to manage because they just don't have the ability to. I would say it's on the rise. It's happening quite a bit, even locally here. I can name a dozen high schools that have changed to synthetic fields. And the problem is that now a lot more of the younger athletes are getting injuries, and those injuries are lagging, and it's making it problematic for them to play at the next level if they even have that chance.
So we have some more time. So if you have any questions, please use the Q&A box and type your question, okay? And we have time for a few more questions. So I'll read for a few minutes, and if there is no question, then I'll call it off, okay? Yeah, it's amazing because I never thought about this deep. So many parameters that goes into that sports field.
Yeah, it's not as easy as most people think. So
Right, and it's highly it is a huge traffic there when that happens, and with that short period, that preparation for that short period is amazing.
yeah, we do a lot of long-term monitoring long-term and short-term to actually we can get down to the point where we know exactly what the soil moisture should be to keep the compaction
and the surface hardness at a minimum, so like the field plays the best and there's less chance of injuries too. And it can be pretty site specific to the field. It may not be the same for the entire field. So it's pretty interesting stuff. At least for me, it is.
Well, it is interesting. And somebody's really working on it. So that's amazing. That's, you basically. Yeah. Anyway, looks like we don't have any questions, and I don't have any pressing questions either. So, so I would just make this call this as a webinar at the end. And today, before I do that, I want to thank you, Dr. Hendry, and also Andrew for excellent talk today. And I'm pretty sure we all have learned quite a bit from this. So thank you so much. I really appreciate it. Okay.